Hi again. As I said in the last video, in physics, a numerical quantity is not just a number. It represents a certain amount of something. A length is a certain amount of distance. A duration is a certain amount of time. A velocity is a certain amount of distance covered in a certain amount of time. A pressure is a certain amount of force exerted in every little bit of area on a surface, and so on. So if I tell you that the length of this marker is, let's say, 13, that doesn't say anything at all, does it? 13 what? 13 inches, 13 centimeters, 13 times the width of my pinky, or my index finger, or my thumb, 13 times its width. I need to tell you what my standard of measurement is. In other words, what a measurement of 1 would represent. That is the job of units. If I include a unit, now I know that the length is 13 centimeters. cm is the abbreviation for centimeters. And a centimeter is a universally agreed upon, internationally agreed upon unit of length, which is about the width of my finger. There is a very precise definition. You could go look it up somewhere if you want to calibrate your own measuring instrument, or just buy a ruler already calibrated in centimeters. If you don't like metric, you could instead say that the length of the marker was 5.1 inches. That's entirely legitimate. Even notice that the numbers are different and the units are different, even though these are exactly the same length, which just goes to show that a number without a unit is pretty meaningless. Okay. I can tell you the length of this marker in centimeters, or inches, or meters, or feet, or miles, or kilometers, or furlongs, or angstroms, or smoots. I can tell it to you in US football fields. I can tell it to you in diameters of an official tournament ping pong ball. I could tell it to you in thicknesses of an official US penny. In fact, I could use any reference length as long as it has an objective, agreed upon value. If I use any of these units, you can figure out the length in centimeters or in inches or anything else you wanted just by units conversion, converting from one to the other. If you know how many centimeters there are in an inch, it's not hard to figure out. Now, what would you think if I told you that the length of this marker was 5.7 thumbs? You'd probably get a reasonable sense about how long it is, but you could not be very precise. Why? Because there is no official standard for a thumb width. Thumbs are all different. Not a good unit. You'd have the same problem if you tried to measure the duration of something in heartbeats, just like Galileo did when he was doing his experiments. Or if you wanted to measure a surface area of something in lasagna noodles. Great if you're working in the kitchen, not so great for physics. Okay, what would you think if I told you that the marker's length was 6.5 seconds? Or 20 square centimeters? Or maybe 1.2 pounds? You know those are wrong, right? But how do you know they're wrong? Why are they wrong? It's because the unit of a quantity tells you more than just how much one represents. It also tells you what kind of quantity it is. Whether the amount is a distance, or a duration in time, or perhaps it's a velocity, or maybe it's an area, or it could be an electric charge, or a force, or a mass, or an energy, or so on, for any other of a very large number of possible kinds of quantity we talk about in physics. In physics, we call these the dimensionality of the quantity. Dimensionality. Sometimes we just say dimensions. Jargon warning. be aware. This is not the same usage of the word dimension as you are familiar with, most likely. You probably have learned that a line segment is one-dimensional. A square is two-dimensional. A cube is three-dimensional. And maybe you've even heard that space-time is four-dimensional. This is not the same meaning of the word dimension. It's related, it's not quite the same. So when somebody uses the word dimension or dimensionality, you need to use context to figure out which they're talking about. Okay? Anyway, so if you're giving a quantity in one particular unit, you can convert to any other unit of the same dimensionality. However, you cannot convert to a unit of a different dimensionality. 1 inch equals how many seconds? There's no conversion, there's no equivalency. There is no amount of time equivalent to a certain amount of space, distance. You just can't do it. By the way, if you've heard that in Einstein relativity, space and time are equivalent, sort of, but not quite. What we do is we measure time differently in relativistic context to talk about relativity so that we can make an equivalency, but it is a different way of measuring time, so it does not change the fact that these are distinct dimensions and you cannot convert from a length to a time. Okay. Anyway, to do physics or any other science well, you really need to be absolutely rock solid on the following 4 points. 1, every physical quantity needs a number and a unit, or it's meaningless. There's one exception. It's called a dimensionless number. There are certain kinds of numbers that don't need and can't have units. I'll let you think about that and discover what they are a little bit later in this lesson. 2, the unit says 2 things. What kind of quantity is being described and how much of it a quantity of 1 would represent. Call that the scale. Point 3, you can convert a quantity from any one unit to a different unit of the same dimension. That basically means changing its scale without changing its kind, like going from centimeters to inches. 4, all units have an official, unambiguous, very precise definition so we can all agree on how much 1 means. Don't use thumbs. One last thing, and this is really super important. Right now, having to deal with units in addition to numbers may seem like a great big pain in the algebra. It probably is. It's more to think about until you get fluent and comfortable with it, and then it becomes very natural. And it's worth doing that because if you respect the units, they'll become your best friends. I totally mean that. They will help you catch math slips, they'll help you catch thinking mistakes, and in fact, you can even use units to figure out the answers to questions without doing all the calculations. It's kind of a cheat. It's called dimensional analysis, and we'll get to that later on too. So, respect the units. It'll pay off. Let's get some practice.